Okay, if we start this process with this first example, in order to be able to do step 1 and split our reaction to half reactions, I first got to check my oxidation numbers of each of these elements. My plus sign is a little bit smaller. It's a little clearer what I'm writing here. And then if I'm looking at this, my zinc is what I see being oxidized here because it's going from a 0 to a +2. And that means that our hydrogen is what's being reduced. And I can confirm that because +1 to 0 is going down and oxidation number is decreasing. So if we pull apart our reaction into our two half reactions, and actually, since we're going to be doing this whole process, it can get a little bit disorganized. So as we're pulling these apart, what I'm going to do and kind of talk about as I'm doing it is kind of try and start in the middle of these lines and give myself plenty of space to write stuff on both sides, and also make sure that my arrows for each of my reactions are all lined up together. And that's going to help make sure that that last step where we combine things back together stays nice and neat and we don't make any silly mistakes. Because since we're going to be kind of adding things up and bringing things down, if my arrows were offset, I could easily bring stuff from the reactant side of my half reactions down accidentally onto the product side of my overall. So that's my general suggestion, is start off with them all lined up and you're less likely to make little mistakes. So I'm going to bring my zinc turning into zinc +2. I'm trying to be nice and neat so you can read everything I'm doing here. And then our hydrogen +1 turning into H2. All right, I have split my reaction into half reactions. Now my next step is going to be to balance my elements, only the ones being oxidized and reduced, though those are the only kind we've got here. So I need to put a 2 in front of this H +1. My zincs were already balanced. Their charges aren't, but I still got 1 zinc on each side, so they're fine. And now I have 2 hydrogens on each side. So my elements are now balanced. And luckily here we get to skip our oxygen-hydrogen steps. Steps 3 and 4 are not necessary because there are no oxygens in this reaction. Don't let the hydrogen part kind of concern you. We only need to do those hydrogens and add those H pluses after we've added some H2Os. So we get to jump straight to step number 5, where we're going to balance the charges by adding electrons. So let's go ahead and make our spaces. You don't have to do this, but I like to kind of visualize and kind of show you where we're putting them so that we know what we're thinking through. But if this isn't helpful in your process, then you can just write the electrons there without the line, or just write it all in all at once. But because I know I'm putting electrons on the product side and that this has to make it match the total 0 charge that I see on the reactant side, that must mean that my zinc +2 was losing 2 electrons, because +2 and 2 negative add up to 0. And then here, our product side is 0. And remember that this 2 affects my charge as well. 2 H pluses have a greater charge overall than just 1 H plus would. So with 2 positives here, I'm going to need 2 negative electrons in order to bring that down to neutral. So now the charges are balanced between each side of each reaction. And luckily, I guess unluckily, this is 2s again, and you're just going to keep thinking that it's always 2, but I promise the next example, it won't be 2. But they are already equal, so I can already go ahead and check that off of my list as well, which means we are ready for our canceling step. So, like I said before, our electrons always cancel, and that's because our electrons are always going to be exactly equal amounts, and they're always going to be on opposite sides of the reactions. Oxidation is always losing, reduction is always gaining. So these are going to cancel each other out, and we are not going to see any electrons in our final overall reaction. Now, electrons aren't the only thing that can cancel. In things that don't have any oxygens, they do tend to be the only thing you need to worry about canceling. But the more oxygens you got and the crazier your reaction is, the more H2Os and H pluses you're going to have there, and sometimes those can cancel. So imagine that you have 3 H2Os on the product side of this reaction and 3 H2Os at the reactant side of this reaction. Because they're equal and opposite, then those H2Os would also cancel out, and you would have no H2Os in your final equation at all. If they aren't exactly equal, but they are still on opposite sides, say maybe you had 5 H2Os here on the reactant side, then you still need to be canceling out these 3 H2Os on the product side. Those are going to completely cancel out with 3 of the H2Os from the reactant side, which is going to leave you behind with 2 H2Os that you would need to bring down into your overall equation on the reactant side. So keep an eye out for those as our reactions get more complicated. But we don't need any H2Os here, and so we don't need to be worrying about canceling them out. So now that we've canceled things out, it's time to kind of add it up. We're going to take everything that's left behind on the reactant side of both of our half reactions. That's going to end up on the reactant side of our overall reaction. And then we're going to go find and write everything that was on the product side of both of our half reactions on the product side of our overall. And these can get kind of long, but just start at the top, work left to right, top to bottom, just the way you normally read. Just be orderly in the way you do this. And make sure everything that was left behind and didn't cancel is included. Space that out a little bit. This one isn't super long. And zinc plus 2 plus H2. And that is our final overall reaction, balanced using the half reaction method. So hopefully that wasn't too scary, too hard. It might seem a little weird and not all of the steps might make total sense. If you want me to explain more of the why behind what we do here, please let me know. Just understand that's something that we normally dig into a little bit more when we get to AP chemistry. So if you're curious about those types of things, definitely talk to me and definitely consider taking AP Chem. So, what I want to point out here might initially frustrate you if you hadn't already noticed it all on your own. But I kind of want to show you this also in my kind of talk about you can do this even if you don't think you can. If you look at our original equation that we started with and compare that to our final overall equation down here, you might notice that technically the only thing that this half reaction method actually ended up changing about this reaction was a single 2. A single 2 right here. And you might have even been able to predict that that 2 would have needed to be here because we had H2 on the opposite side. So some of you might think that this is just extra work, busy work that chemists do just to look smart or something. It's not. This is just a very simple example we gave you so that it wouldn't be too scary the first time. But because it's so simple, it kind of doesn't seem like it has that much of a purpose here. But it does. And you'll see this more and more as we work some more intricate and involved examples. But I want to point it out here, not to say that it's pointless or you might not ever understand why, but to point out that you might be able to guess how to balance some of these reactions, especially the ones without oxygen, without having to do the whole half reaction method. So while you're working on building those skills on being able to do this half reaction method better and better, also understand that it really is just balancing atoms and then balancing charges. And you know how to balance atoms, so you can generally make a pretty decent guess at what that final overall reaction is going to be. Like I said, especially if it doesn't have any oxygens in there. And combined with some partial credit, if you kind of mess up and muddle through the rest of those 7 steps, you might actually be able to get a decent amount of credit on some of these problems. So definitely don't skip these problems when you get to the test. Don't just skip them on your packet. Keep working on building those skills, like I always say, and moving forward, getting better at that next thing. And I think you'd be surprised at how far you can get in some of these. So let's go ahead and move on to another question.